Welcome to HurricaneCenterLive.com. I'm Alex Garcia, Director of the National Tropical Weather Conference and Executive Producer of these programs. These programs are made possible by USAA, the South Padre Island Convention and Tourist Bureau, and Plylocks Hurricane Clips. These programs are also a team effort with Bill Reed, the former Director of the National Hurricane Center, and Tim Smith, Chief Meteorologist of KRGV-TV. And now, here's Tim Smith.
Thank you, Alex, and good morning, everybody. Welcome to NTWC Live for Wednesday, November the 11th. It's Veterans Day. Glad to have you all along today, and thank all of our veterans who are watching for your service to our nation. We appreciate that. Another great program scheduled for you today. Going to dig deep. Going to get into the weeds today. I think it's going to be a lot of fun, some of the stuff we're going to talk about today. But before we get to that, we want to thank all of our sponsors who make these programs a possibility. We want to thank Plylocks, folks who make these little hurricane clips. There you go. Can you see that guy right there? That thing really looks like this. I can show you with my homemade little prop right here. Simply slide those things on here. When you're ready, you slide it into your window. When the hurricane's over, you pop them right back out, and your window is safe from the hurricane. Plylocks Hurricane Clips. Thanks to USAA, who's a proud part of many of the programs we do with the Storm Science Network. Not just this, but many other programs as well. We appreciate that. And the host of the National Tropical Weather Conference, South Padre Island, the SBI Convention and Visitors Bureau, a sponsor of NTWC Live and a sponsor of the National Tropical Weather Conference. And if we meet in person in 2021, we'll be right back on South Padre Island once again. Looking forward to doing that. Great program for you today. Let's get right to it to find out what's going on today and then get into the program with our host, Mr. Bill Reed. Bill, thank you for your service to our country on this Veterans Day.
Hey, thanks a lot. Yeah, I was just thinking about USA sends things out every now and then. I've now had 48 years of having USA insurance. So that's about how long ago I was starting out my career in the Navy back then. Yes, we have a great program, and normally on Veterans Day, you would not expect to have a whole lot to say about what's going on in the tropics. However, we'll take a look at it. Okay. This is a wide view of the Atlantic Basin and in the water vapor imagery. Starting out here in the west, you have Ada spinning along just off the west coast of Florida. We'll talk a little bit about that. Pretty good stream of westerlies began impacting the area there and helping to move it forward. There's actually a pinched off high down here in the Gulf and another one east of Florida, and it's being channeled up to the north on the east side of the ridge over the open Atlantic. Down here in the Caribbean, the tropical wave that's been advertised in the outlook for several days now looks a little more concentrated in the thunderstorm activity than before. It's forecast to move steadily westward, and I jokingly call it the evil spawn of Ada because it's got a similar genesis and then track prognosis in the models, at least, that we had earlier on Ada. Sometime over the weekend, it's expected to become a tropical cyclone. A few days later, be approaching the northeast coast of Central America. And then way out here in the subtropical Atlantic between the Azores and Madeira Islands, we have Theta. Started out as a subtropical cyclone, a core of warm, moist air trapped between westerlies well to the south and westerlies well to the north. Thus, it got its act together. Forecast to steadily move eastward and not expected to impact land that we're looking at now. A little closer look, this is the latest visible imagery on Ada, where you can see the eye very clearly now. And the hurricane hunters were out in it earlier this morning and found that it re-intensified to hurricane strength. A small area of hurricane force winds out to the east of the center on the recon flight. One significant rain band moving onshore right about now, and perhaps another one or two forming. We'll look at the details of the forecast a little later, but it does look a little healthier than it did this time yesterday. Close up on Theta, and it's been exposed. The low-level circulation has been mostly convection-free, though there looks like a pretty good blow-up on the northern side of the center here this morning. And the general thinking is it'll maintain its tropical characteristics and hold steady in intensity as it moves east. This is the outlook and what I just talked about on the on the suspect 98L area is 80% chance of developing mainly from this weekend going forward. Quick look at Eta. The latest forecast has it making landfall early tomorrow morning, just north of the Tampa area, which throws the threat of the higher surge values again down the coast into the Tampa area, and even further south there'll be a storm surge issue along the beaches and barrier islands of the west coast of Florida. And with that in mind, the Hurricane Center has this the peak surges showing up as 2 to 4 feet from Benito on up to Boca Grande, and a large area 3 to 5 feet, including Sarasota and the Tampa Bay area, and then 2 to 4 feet as you get up in towards the Big Bend of Florida, near where the center makes landfall. And again, there's enough uncertainty as exactly where that'll make landfall. It spreads it a little farther north than you might expect looking at the Prague there. Rainfall, 4 to 6 inches in a stretch along the coast here. Judging from the rain band and how slow the eastward progression will be, it wouldn't surprise me if we see some isolated amounts in the 6 to 10 inch range, maybe even approaching a foot by the time all is said and done going up the west coast. Beta was an overachiever down in South Florida, where they had a large area of a foot or greater rain from the Fort Lauderdale area down to northern Miami-Dade. Back here, quick look at Theta. Again, this has been a consistent forecast all along, very slow movement to the east, becoming post-tropical after the weekend, east of the Northwest Africa and the west coast of the Iberian Peninsula. One more thing I wanted to look at here. This is just the ensemble forecast off the last night's ECMWF. A lot of ensemble members hold this system together, and in fact, the more northern tracks of it lower the pressures enough to consider a hurricane, maybe even a major hurricane. All that's on the table until we get a actual development of the storm here. Okay, that's it for the current tropics here. We've got 2 more interesting speakers for you today. I'll introduce them both and then turn it over to our first speaker. Our first speaker will be Dr. Brian Dzwonkowski. He's a professor in the Department of Marine Sciences, University of South Alabama. His specialties are coastal physical oceanography and air-sea interaction. And he caught our eye. He had recently published a paper called Marine Heatwaves and maybe some indications on rapid intensification, which he will talk about. And our second speaker, back for at least the 5th time this year, Dr. Phil Klotzbach, who's at Colorado State University in California. So he's going to talk about the 1933 season, which was also a very active season. So without further ado, Brian, take it away.
Thank you. Yeah, so this work just recently came out in September in Nature Communications, and I'm very excited about it because it was well timed for this hurricane season with all the activity we saw, particularly with a lot of landfall storms intensifying before landfall. And so, at the time when I was doing this research, I was surprised to see Hurricane Michael basically intensified multiple times, particularly when it came across the shelf and made landfall in Mexico Beach, Mexico City, Florida Panhandle. And so that sort of piqued my interest is, what may have caused the intensification prior to landfall. And I just so happen to have a mooring offshore of Dolphin Island, so it's somewhat far away from where it made landfall. But I wanted to see what was going on with the ocean temperatures. A lot of times we're just sort of stuck with sea surface temperatures through buoys or satellites. And so I had an opportunity to look at the full water column data. And so when I started looking at the full water column data, what I noticed was in the 13-year record that I have from this mooring site, the heat content of the ocean or the coastal ocean. And in this case, I was just using the depth average temperature because it's a pretty good metric for heat content in the shallow ocean. But the depth average temperature was at a 13-year record, and it was well above typical levels. It was sort of an extreme event. And so that got me thinking, well, if the temperatures were at an extreme level, sort of what does that mean for hurricane intensification? And then also, how did it get there? How did it become an extreme heat content event, right? So, how did that ocean battery get charged? And so what I was able to do was backtrack the warm water intensification, that sort of marine heat wave, to a series of two events where you saw earlier in the season. So Michael came through in early October, but prior to that, we had Tropical Storm Gordon come through the area and basically mix the water column along the shelf, right? And so normally we think about hurricanes pulling heat from the ocean, and they do that, but they also mix the ocean. And that mixing is oftentimes the primary factor in why you see cold wakes behind hurricanes, is that mixing factor. It's more mixing than it is heat loss most of the time. And so on a shelf environment where you have a constrained ocean, right? The bottom, there's a bottom boundary that the ocean can only mix so deep because you hit the bottom, right? And so a lot of the mixing energy is lost because you're not going to stir up any more cold water because you have a bottom that just prevents any more cold water from being mixed upwards and cooling the surface ocean. So Tropical Storm Gordon comes through, mixes out all the cold water on the bottom of the shelf, and then just sort of goes off and does its thing. Well, right after that, we ended up with an atmospheric heat wave coming through the area. And so you have a well-mixed water column. So the whole water column is now warm. It's no longer hot on top and cold on the bottom. But we have this uniformly warm water column that then gets reheated. The upper ocean gets reheated by an atmospheric heat wave. And that sort of supercharges the ocean battery prior to the landfall of Hurricane Michael. And so it was really this coupling of events, this compound event where you saw Tropical Storm Gordon come through, mix the ocean. So that pushed upper ocean heat downward and cleared the shelf of any cold water. And then you had the atmospheric heat wave come through and reheat the upper ocean. And so you had this sort of combo effect that really energized the coastal ocean. And again, I didn't have the data to say this is what allowed Michael to intensify, but previous work from other people has indicated that if you have really warm shelf conditions, you're making a setup that's conducive to intensification. And then lo and behold, this year with all these storms, we have some similar setups going on, right? Where we had, initially, I was really concerned about Laura, right? Laura was targeted for the Alabama, Mississippi Bight area in its early forecast, and then sort of shifted to the Louisiana, Texas area. But that had Hurricane Laura come through the Gulf and mix up the shelf about 2 or 3 weeks before the instance of Hurricane Laura. And so this was sort of a very similar setup where you had a mixing event followed by really, really hot Gulf of Mexico conditions, weather conditions. Then we had another event, Hurricane Sally, which more directly affected me. You had Marco come through the area, Hurricane Marco come through the area. And then 2 or 3 weeks later, Sally starts energizing and just basically parks itself over the shelf. And because we had a mixing event followed by Gulf of Mexico warm conditions, we probably had a similar setup in these two cases, at least in this year. And so it does look like this mechanism may not be as rare as I thought it might be. It may be more common, and it's something I'm sort of looking into, is how often do we see sort of storms follow tropical activity followed by warm conditions. And so we did see that it appeared to play out in this hurricane season. And so I was actually kind of shocked to see this setup arise multiple times in this hurricane season. And so that's really been, that was sort of the gist of this work, was just sort of seeing this sort of compound event that could supercharge the ocean heat content on the continental shelf.
You're muted, Bill.
Fascinating work, Brian. We'll get back to you with, I have some questions. We'll get back to you, but we're going to hear Phil's talk on a 33 hurricane next and then get to everybody's questions. So Phil?
Well, thanks so much. Very good talk, Brian. Yeah, I wish we could know what things look like in 1933 to see if we had similar kinds of. We don't have very good. We have some sea surface temperature data, but really don't know exactly what the ocean heat content and what the temperature structure of the ocean was like back then. But we've had a gangbusters year this year. But I do want to share talk a little bit about the 1933 hurricane season. Which was a really, really active hurricane season. And this is work that we started and it just got accepted for publication in the Bulletin of the AMS. If you're interested, you can search record-breaking 33 hurricane season. It's on the AMS website, just not in its final form yet. But 33 was an extremely active season. And here's kind of what got me started really interested in this season. Here's the weather map from September 4th, 1933. If you look in the southern U.S., you can see, there's a low pressure onshore in Florida. That was a Treasure Coast hurricane. It was a Category 3 hurricane, estimated to have winds of 125 miles an hour, made landfall, as you would expect, on the Treasure Coast of Florida. You turn your eyes to the western Gulf of Mexico, you see another kind of ominous-looking low pressure area. That was the Cuba-Brownsville hurricane, which, as you would expect, made landfall in Cuba, and then made landfall in Brownsville. It was bearing down on Brownsville, Texas, made landfall as a Category 3 hurricane in Texas just 23 hours after the Treasure Coast hurricane. So we had two high-end Category 3 hurricanes hit the United States in 23 hours. Now, obviously, in 1933, we did not have social media, but I can imagine Twitter would be absolutely blowing up if that were to happen today. So whenever you talk about active seasons and active periods, this is probably a record that's kind of tantamount to the 56 game hitting streak of Joe DiMaggio. I'd be really surprised if we see this event happen in our lifetime. Although 2020 has certainly shown me some things I never thought I necessarily would see either. So here's a track map from the 1933 hurricane season. So we have greens are tropical depressions, yellows are tropical storms, reds are the hurricanes, and purples are the major hurricanes. We had 20 storms in 1933, but 1933, we didn't have ships, we didn't obviously have ships, but we didn't have aircraft reconnaissance. We didn't have satellites in 1933. So if you go into the Eastern Atlantic, we probably missed some storms. How many did we miss? Nobody can say for sure. Probably several, because several is a nice vague word. But it's hard to know exactly how many we missed. But obviously, we could have had several other storms exist in 1933 beyond what we have observed. But in addition to those 20 storms, we had 6 major hurricanes and an extremely active season in the Caribbean, and especially for Mexico. I'll talk more about that here in a couple of minutes. Just for comparison, here's the 2005 season, which is what most people consider the most active season on record. It was the most active season on record for named storms until very recently, when 2020 has surpassed it for named storms. In terms of accumulated cyclone energy, which if you've heard me talk before, I talk about this a lot, it's an integrated metric that accounts for the frequency, the intensity, and the duration of storms. 1933 is actually ahead of 2005, even though 2005 obviously had extremely intense hurricanes, and both of these years are well ahead of 2020. Here's a track map from 2020, courtesy of my friend and colleague, Ethan Gibney at the HurricaneCenter. This is tracks through about a few days ago, so we don't have the full track of Eta or Theta on this map, but certainly in Theta, I guess, given where it goes, you have to have an inset because Theta is going to go off this map here in a couple of days. But obviously, it's been an active season, but kind of like we saw in 33, 2005 or 2020 has been extremely active. Western Caribbean and Gulf of Mexico. We had a lot of storms in the Eastern Atlantic, but you see really very few reds. Really the only classic Cape Verde hurricane that we had this year was Hurricane Teddy, which most people don't remember. It was a powerful major hurricane, got up to Category 4, made landfall as a post-tropical system up into Nova Scotia. So how does 1933 compare with 2005? Here's the ranks. I just updated the ranks because 2020 just bumped both of these down a notch. But both of these obviously very, very active seasons. But just to draw your attention to accumulated cyclone energy, the most on record in 1933. So an extremely active season, basically the 2005 before we actually had 2005. And it was very active for landfalls. It had 4 landfalling hurricanes hit the U.S. and 4 landfalling hurricanes into Mexico, which is the most on record to hit the coast of Mexico. We'll see if we can approach that record this year. We'll see, given the system currently in the Caribbean. But it was a very active season. Again, we had those 2 landfalling hurricanes hit 23 hours apart. We had another Category 1 hurricane hit in a similar location in the Treasure Coast of Florida. But the most impactful storm of the 33 hurricane season was actually along the East Coast. It's that Chesapeake Potomac hurricane, which was a major hurricane offshore, weakened to a Category 1 hurricane before it hit eastern North Carolina, and then went right up and brought the strongest winds up into the Chesapeake Bay, caused a tremendous amount of storm surge in that region. So here's a surface map of the Chesapeake Potomac hurricane, and a zoom in on the track. Oops, sorry. And here are a couple of images that had a tremendous amount of storm surge associated with it. We had about 7 feet of storm surge in Norfolk, which is the figure on the left. And then on the right-hand side is some storm surge from Ocean City, Maryland. 47 fatalities from this storm. So the current estimate of the damage was about $40 million, which doesn't seem like very much, but given the growth in population that we've seen in that area, this storm, if it were to make landfall today, would likely cause over $30 billion in damage. How much damage have the storms in 2020 caused for the U.S.? It's estimated about 35, maybe 40 billion. So one Category 1 hurricane in a fairly densely populated area can cause more damage, economic damage, than we saw from the 6 hurricanes that have hit the United States in 2020, because as you know, it's all about location in terms of the economic damage that they would cause. The storms of 2020 obviously have been devastating to the areas that they've impacted, but we haven't had we haven't had a hurricane yet hit a major metropolitan area. So this is just some video footage from Ocean City, Maryland, of the Chesapeake Potomac hurricane. I just thought it was really, really cool that someone had archived this footage. So this is just showing some of that storm surge coming on shore. Just really quite remarkable. Again, this is Ocean City, Maryland. So just kind of some cool footage here. In the interest of time, I won't show the full footage, but pretty cool that they actually have this archive footage all the way from 1933. But you can just see all the storm surge into Ocean City, Maryland. So a very impactful storm for the Mid-Atlantic region. And here's the storm tide from the hurricane. This is from the slosh model, the slosh model is what the HurricaneCenter uses for its storm surge forecast. So this is basically a hindcast. So it's basically saying, taking the observed track and intensity of the storm and an approximate estimate of what its structure was like, and estimating how much storm surge it would produce. You can see a tremendous amount of storm surge into Norfolk, all the way up the James River, up into Chesapeake Bay, and you can see obviously a lot of storm surge into Maryland as well. Just to kind of focus again, we're going to shift our attention further south from the United States down into Mexico. We had 4 hurricanes hit Mexico in 1933, which is the most hurricanes to make landfall in Mexico from the Atlantic side in a calendar year. The most impactful storm of those was the Tampico hurricane, which first made landfall as a Category 4 hurricane in the Yucatan Peninsula, weakened as it went across the peninsula, re-intensified up to a Category 2 hurricane, just below major hurricane strength when it made landfall in Tampico. But it caused a tremendous amount of damage to Tampico. You can see on the right-hand side some of the aftermath, people getting supplies, and just kind of raised that whole area. A lot of storm surge into Tampico. About 200 fatalities, and the population, or 75% of the homes in Tampico were destroyed by this hurricane. And the population of Tampico in 1933 was about 100,000. Now that metropolitan area is about 1 million. So obviously, were this storm to make landfall today, the damage would be quite a bit worse. So now I want to take a little bit, instead of focusing on individual storms, kind of focus on the season and compare it a little bit with 2005. So the bottom line, that green line, is the average ACE per month. So you can see the season peaking in September. And then we have 1933, which is the blue line. So 1933 effectively followed the canonical seasonal cycle pretty well, but just effectively on steroids, just like twice what you would expect each month. Whereas 2005 was more of a long, drawn-out season, a ton of stuff in July. August and September, just a little bit above normal. And then just a very active late season in 2005. And we remember 2005 went into December as well. So 2005 was more of a long, drawn-out season, whereas 1933 was just very peaked. Basically, it followed the canonical seasonal cycle, just a lot more peaked. As you would expect, given how active the season was. We did have large-scale conditions that were quite conducive for hurricanes. So this is from a reanalysis product. So, back in 1933, we didn't have a ton of observations, but we do have enough observations to give us some idea as to what the large scale was like. And as you would expect, the large scale was very conducive for an active season. We had low shear. Too much shear is detrimental for hurricanes. So if we're looking at Hurricane Eta right now, you can see there's a lot of shear. Too much basically kind of tilts the hurricane circulation, also promotes entrainment and bringing in of dry air into the circulation, which chokes off the thunderstorms. Low shear in 1933. Also, we tended to have warm water in the tropical Atlantic, which was normal. Warm water provides more fuel for the storms. We also had cold water in the tropical Pacific. Likely we had a weak to moderate La Nina event. La Nina tends to reduce your shear. And probably most importantly, we also had high heights over the Atlantic provinces of Canada. So the circulation around that high pressure basically prevents these storms from recurving out into the open ocean, driving them farther west towards the United States into the Caribbean. So basically when you have high heights over the Atlantic provinces of Canada combined with overall conducive atmospheric environment, that's very bad, because then you're not getting a bunch of so-called fish storms, you're getting storms that have impacts on land masses. So now I want to move on and focus a little more on the sea surface temperatures. We did have a weak to moderate La Nina event as best we can tell. Again, fairly limited observations of what was actually going on during that time period, but given the limited ship traffic that we have, we estimate a weak to moderate La Nina event was going on. And again, we did have a warm tropical Atlantic. And these are anomalies taken from a base period of 1901 to 1930, which would have been the 30-year base period they would have been using had they been doing 30-year base periods like NOAA does now. Obviously, if we looked at it minus the current sea surface temperatures, everything just looks really cold given the long-term warming trend. One thing we also looked at was, did we have kind of subseasonal variability that really helped enhance the hurricane season at particular points during the year? And so one of the large-scale factors that we look at for kind of trying to identify kind of peaks and valleys in a hurricane season is what's going on with the Madden-Julian oscillation. And as you would expect, the Madden-Julian oscillation was discovered by Madden and Julian. And basically, it's tropical convection that propagates around the globe about every 30 to 70 days. And as it does so, it obviously alters where your thunderstorms are forming, but it also alters basically your vertical wind shear. The Madden-Julian oscillation is not always strong. Sometimes it's really weak or basically non-existent. But when it propagates around the globe, it alters where your thunderstorms form. It also alters your vertical wind shear. And so we find for the Atlantic, the most critical factor is the modulations of the vertical wind shear. So if you look at this schematic, when you have upward motion over the Indian Ocean, going into that, basically you have air flowing into those thunderstorms, going up and then out at upper levels. Bill Gray, the founder of the seasonal forecast mentor at CSU, so I always talk about the in, up, and out circulation. So lagging that deep convection over Indian Ocean, you have low-level westerly flow, upper-level easterly flow that counteracts your normal vertical wind shear in the Atlantic. So when you have the Madden-Julian oscillation enhancing convection over Africa and the Indian Ocean, that reduces your shear in the Atlantic. And so what we looked at was, how did the Madden-Julian oscillation impact hurricanes in the Atlantic in 1933? And so this is basically what's known as a phase-space diagram, but all I want you to notice is that basically if it's near the center of the circle, it's kind of weak, but if it goes way out from the circle, it's much stronger. And so what we found was that we think effectively the Madden-Julian oscillation helped enhance storm activity in early September and really knock down your storm activity later in October. And we saw similar influences in 2020. We've had a bonkers active season, but we had about 10 days in late September with no storms. And we think the Madden-Julian oscillation in 2020 kind of knocked down, gave us that nice little break before, everything kind of really ramped up back in October. So finally, one of the things we wanted to look at was, could we predict this 33 hurricane season? With the current statistical models that we use at CSU, let's see if we can predict what happened during 33. Can we predict it's going to be a very active season? So here are the sea surface temperature anomalies in 1933 in May, the differences from average. So you can see warm in the Atlantic. We're starting to see hints of a La Nina event, but it's a pretty messy signal in May. So what we said was, let's take the current predictors that we use, and these are the predictors that we use in our June seasonal hurricane forecast at CSU, and let's what we did is we took our historical climate data, which in this case we went back all the way to 1878. So we built a model from 1878 to 1932, built equations off of that, and said, let's apply it to 1933. Can we predict the 33 hurricane season? And also, are these predictors that we've developed, that we've picked for our current CSU scheme, do they actually work on data, over 100 years ago? And the good news is it does. And so here what we have is our values of accumulated cyclone energy, so that integrated metric, so higher levels of ACE indicating a more active hurricane season. So higher ranks indicate more activity. So our model from 1878 to 1932, you get a correlation of 0.6. So not perfect, but you get a reasonably good correlation. And the red dot is 1933. And that was what we forecast, 165 ACE. So it was below what we actually got, but a well above average season. Basically would count as hyperactive using NOAA's current definition. Likewise, we said, well, can we do it with our August scheme? And August, obviously, you're 2 months into the hurricane season, but about 95% of all your major hurricane activity occurs after the 1st of August in an average season. So again, we're still kind of developing a La Nina event. The Atlantic is very warm. So we did a very similar methodology. We said, let's build a model off of 1878 to 1932. And then let's see how well it was forecast 1933. And so we do the exact same thing here, and the model forecasts an ACE of well over 200, extremely active season. So overall, it was good to see that our current statistical models that have been built over, say, the last 40 years worked well on forecasting hurricane seasons over 100 years ago. That indicates they're likely fairly robust, and also was able to delineate that 1933 would be a very, very active hurricane season. So it helps give us confidence that the models that we're currently using hopefully will continue to work in the future, because if you can build models on more years of data, you have more realizations of how the atmosphere and ocean are likely to behave. So just in conclusion, 33 was extremely active. Hopefully it convinced you of that. The large-scale environmental factors certainly favored this active season, and our seasonal models from CSU would have anticipated this very active hurricane season. They certainly don't work perfectly every year, but in general, these models do work reasonably well, and certainly for 2020, we did predict a very active season, and I think everyone would agree 2020 has certainly also been very active. So I'm happy also to answer any questions that you may have. So thank you.
All right, Bill is back.
Bill is back. Yeah, the housekeeping was knocking on the door. Sorry about that. That's fascinating stuff. Let me get back to Brian on a question I had. It was interesting this year, the product I look at for heat content that on the University of Miami's website, it indicated it was much warmer than normal across, much higher than normal heat content, especially across the Caribbean. And it sure pans out. It makes sense with the storm activity we've had down there. Did you happen to look at marine heat waves and hurricanes where there wasn't an antecedent hurricane to mix up the shelf? And the storm I was thinking about, we had a tremendous amount of a tremendous heat wave going on in the summer of 1983. And we had Hurricane Alicia that came into Houston, and sure enough, it did a bit of a rapid intensification right up to landfall.
Yeah, I really haven't. I really haven't had a chance to explore anything outside of this sort of one event in particular. But I am happy to report that that is going to be a future direction of some research that I'm going to be doing in the next year or two. And so this is something I am actually really keen on, is to better understand when storms intensify before landfall and how that couples with the ocean environment. And so I actually haven't looked at really any other events besides this one in particular, but that's something that is sort of, that's sort of the next page of this work, is to say, all right, that worked for this one. Let's take a broader view of this sort of mechanism and see when things are intensifying, is this likely to be a cause, or how often this happens, and then what are some other potential ocean storm interactions that we might be able to figure out from storms that intensified over landfall. I mean, my general sense is that, what the ocean's doing over the shelf is sort of an order two thing, where everything else has to be sort of right for a system to take advantage of that extreme heat content on the shelf, right? So it's sort of like all the atmospheric environment has to be in place. And then if you have a warm, really warm ocean, then it can really, energize the storm. But if the atmospherics aren't right, then it doesn't matter how warm the storm, the coastal ocean is going to be. That's going to be sort of a secondary thing, is my general feeling. And so I'd be curious to see how other storms that intensify, are they coupled to the ocean? How important is that the coastal ocean environment as they're making landfall? So that's sort of a long answer to your question. Of the short answer being no, I really haven't looked at other storm events.
Yeah, it's kind of fascinating. I think the other one, you're probably the same kind of issues with to deal with on that. But I would think with a warming climate, you're getting a warming ocean, and then you combine the warming temperatures, especially along the continental boundaries of the oceans there, that if what you're finding holds true a lot of times, that this may be something that climate change would have an aspect to with hurricanes.
Yeah, and I also know it doesn't necessarily have to be a storm that comes through and mixes the coastal ocean. I mean, that's going to be most typically what you're going to get in the subtropics during this time of year. But really, it could be any kind of wind event that's capable of breaking down the stratification and basically mixing that colder water and basically clearing the shelf of its cold water reserve. It doesn't necessarily have to be a tropical storm, but that's typically what's going to be strong enough to break down the seasonal stratification that develops in the summertime.
Cool. Phil, I'm always fascinated with the reanalysis data before we had the kind of upper air networks that we've had since World War II. How comfortable are you with what you get for output on the like the 500 millibar patterns in there? Is it something that, but being averaged over a longer period of time, you have more confidence than if you were looking at, say, the environment around a specific storm?
Yeah, I mean, I think the longer the averaging period, you're going to have more confidence. Also, to basically a lot of effectively what these reanalysis products have is they're based on surface. It's all surface data. All they use is basically sea level pressure, and then everything, and sea level pressure and sea surface temperature forcing, and then everything else is basically effectively just hydrostatics. When you're looking at over large time periods, you get reasonable patterns, and also too, if you were to say, instead of looking at 500 millibar heights, look at pressures, you get a similar kind of pattern. Over the Atlantic provinces, you could use pressure and it would give you a similar pattern. Also too, because that area that we're focusing on is Eastern US, Atlantic provinces of Canada, you do actually have barometers, you actually have station data. It's not as much just the model filling in whatever it thinks might have happened in these big data gaps. So obviously, as you go back in time, the data is less certain. I'm showing you like the ensemble average. This reanalysis is 56 ensemble members. So in the paper, we go in and actually look a little bit at, because basically what you'll have is kind of like you do with, like you show with forecasts for this potential system in the Caribbean. The reanalysis also uses an ensemble to try to estimate the uncertainty in these values, because obviously you have uncertainty today, but you had a lot of uncertainty in 1933. But the stuff over land, or the stuff close to land, is probably reasonably well constrained given the observational network. And you can kind of see if this ensemble spread is small, then you likely have enough data to kind of constrain it to be somewhat close to reality. Whereas if you have this enormous ensemble spread, that indicates you likely have, you don't really know what was going on. So thankfully now we at least kind of can better quantify the unknowns. So I guess, what is it? Was it Rumsfeld used to call it, like the known unknowns and the unknown unknowns? At least these are more known unknowns as opposed to the unknown unknowns. But yes, as you go back in time, the data obviously does get less certain, which is why when we do our statistical modeling for hurricane seasons, we mostly use the last, say, 40 years. We have high resolution satellite data we can pretty well constrain. We know the values are pretty well estimated. But yes, as you go back in time, the data certainly does get less certain, which is why we normally look at sea level pressure, low level winds, things that are most closely tied to what actually you are measuring in these reanalysis.
Cool. That was a I'd never seen output you had on the Chesapeake. I knew of the Chesapeake Bay storm, but that's the first I've seen of the output on it. And it's kind of stunning that a Category 1 hurricane creates that much damage up there. If you had we've looked at a what-if scenario of running Isabel's track very close to that track that the 33 hurricane took, and the storm surge is phenomenal at the high-end Category 2.
Yeah, there's a lot of surge up into that region. And, you know, one of the other things that we've recently talked about is recategorizing hurricanes by pressure as opposed to wind. And that 33 hurricane was a Category 1 by wind, but it had a pressure, I think it was 963 when it made landfall, which is borderline what we had for a major hurricane. Our major hurricane threshold is 960. So it was a pretty large storm. And as you know, these large storms, even if the winds aren't necessarily that strong, it can have a large storm surge associated with them. So, you know, you got 7-8 feet of storm surge up into Norfolk. And like you said, like Isabel, when Isabel came through, everyone was talking about kind of using 1933 as the one analog storm. It had Isabel tracked slightly differently. You know, it was still bad, but the surge would have been, you know, through the roof. And if you look at that, the slosh model run for that 33 storm, I mean, the 8-9 feet of storm surge all the way up the James River. And there's certainly, you know, getting these kinds of storms in fairly densely populated areas, you can see really tremendous amounts of economic damage.
Yeah. The U.S. Navy was not happy with the what-if scenario for Isabel. What you got from the audience, Tim?
We got a good question from Casper, who's watching today, and where they're a little bit concerned about the storm sitting just off the west coast of Florida. It's a little chaotic over there today. He's asking how sea surface temperatures in the Australian region impact the tropical system in the Atlantic. Is there any data that helps with that? And I guess that's for Phil.
Yeah, so basically what we're looking at when we do our seasonal forecasts is effectively these are before the hurricanes tend to form. So it's not saying that something that Australian sea surface temperatures when a hurricane is out there are really significantly impacting the storm itself. What we're looking at over there is basically that kind of gives us an idea of overall structure of what ENSO, El Nino, is likely to be doing. And so that's how that one actually works. It's related to ENSO and how the ENSO teleconnections are then going to impact the hurricanes in the Atlantic. So when we're doing seasonal forecasting, you know, when you're doing a forecast for, you know, Hurricane Eta, you're looking at, okay, what's it going on in the Gulf of Mexico? You don't necessarily care that there's an El Nino in the Pacific Ocean. You just know, hey, there's less or more shear or something like that. But that, when you're on a seasonal level, you're looking to kind of see what are the large scale conditions basically around the globe that are going to drive conditions to be either more or less conducive over the course of the season. Because basically a seasonal forecast is saying, you know, okay, the shear should be lower overall this season. We don't know where the storms are going to form, but we know the shear is going to be lower. So overall, if the shear is lower, your odds of formation are higher. And that's kind of what these seasonal forecasts are doing is, you know, if the conditions are, you know, a little bit more conducive than normal, then we probably have a little more storm activity than normal. But if they're like this year and conditions look really conducive, we're probably going to see a whole lot more activity than normal. And that's basically the way that these seasonal forecasts get. The way Dr. Gray started these in the 80s, and we still do, is we're looking kind of from where these teleconnections and how large-scale climate patterns kind of load the dice to make the season either more or less active. And then obviously, when you have the individual storms, then you focus more on like what Brian does, like what do the shelf temperatures look like, what's the stratification and all that stuff, and what's the shear and everything else for the individual storm.
I'm curious about the 1933 season in particular, where we are here in deep South Texas, the Cuba-Brownsville storm, and there was one a month earlier that came through, very similar track. And the population of Brownsville then was 22,000, and now it's 200,000. And the population of this community has gone from, 50,000 to 2 million. So I'm just scared to think of what that could do nowadays,
Yeah, and I'd be curious, seeing those two storms did take very similar tracks, what the atmospheric environment was in between, because maybe something like what Brian had was happening that year. We may have actually had something like that year. It would actually be interesting to look and see what the temperatures were like in the interim between those two storms.
And it was, the first one was the weaker of the two. The Labor Day storm was the stronger. The Cuba-Brownsville storm was the stronger. So Brian, that might play into it, because just a month apart, that could play into your long-term research. Interesting stuff.
Yeah, that sounds like a very similar setup, where you clear the cold water off the shelf, and then you have time to rewarm that upper ocean. That is really the sort of the 1-2 combo that really supercharges the ocean. Yeah, I mean, some of the details I didn't get into is it's not just mixing the heat downward into that bottom layer, but when you break down the stratification, that allows the incoming solar radiation to absorb better, deeper into the water column as well. So you're not sort of, kicking more heat back out by trapping it all into a shallow layer. When you break that stratification down, the incoming solar radiation can mix further down as well. So it's not re-radiating heat more rapidly. So there's sort of a double whammy. You're pushing heat down, and you're also changing the thermal structure so that the incoming solar radiation absorbs better and you don't re-kick heat back out to the atmosphere. So it's sort of a twofold effect, which I didn't get into. That sort of initial mixing plays a role in two ways.
One of the things, it just came to mind that, fishing is good here because 100 fathom curve is so close to the coast. It's closer than it is along a lot of the U.S. coast, which means that shallower water is a narrower band here than what it is, say, where you are. So that would be an indication we don't have that shallow bottom, so we may not see as much of that rapid intensification. Does that make sense?
Yep. So there's going to be a range of things, right? So yeah, certainly shelf width is going to play a big role in how important this sort of cold water, having or not having a cold water reserve on the shelf, and then also residence time, right? So if you have a lot of shelf circulation, you can clear all that warm water, that mixing that warmed the bottom water, if that has time to clear out before the next storm. So if you have a really strong coastal circulation happening before that, you could basically clear the system of that warmer bottom water before the next storm comes through. So there's a lot of sort of moving parts here. But usually, Gulf of Mexico, summertime, the wind usually doesn't blow too strong. So after you get a storm that comes through, there's not a lot of wind to drive the coastal circulation in some of these shelf areas. And so, there's a lot of variables that will vary the relative importance of this sort of 1-2 mechanism. In particular, as you highlight, shelf, the width of the continental shelf is definitely going to play a role.
I think the scope of your research is growing because there's so much coming in. Again, Casper's suggesting that 2004 Bonnie followed by Charlie may be a good example to look at as well because of how strong Charlie was at the last minute. All right, Bill, any last questions or comments, Bill? Good stuff today.
Yeah, it really was. No, I think it was very fascinating. We always learn something new at one of these. That's what's so great about them.
Absolutely. Well, gentlemen, thank you as always. Phil, thanks for being back with us once again. We appreciate the many times you've been with us. And Brian, welcome to the program. We hope to have you back as your research continues to unfold in the years to come, because I think we're going to learn a lot from what you're doing. I think it's good stuff.
Thank you.
So guys, thank you, Bill. As always, thank you for your work today. Appreciate the insight and the questions. And everybody who's been watching today, we appreciate it. Casper, we're thinking about you over there on the west coast of Florida. Be safe as the storm sideswipes. You mentioned that it's quite chaotic there today because you're dealing with a hurricane just offshore. So stay safe and do what you need to do. I want to thank our sponsors once again, Plylocks Hurricane Clips, USAA, and the South Padre Island Convention and Visitors Bureau. We hope to be back there very, very soon and get this vaccine done, and we can all meet again in April on South Padre Island, Texas. So that's it from here. We're getting close to the end of the hurricane season. We'll still have a few more programs to go, but then after that, we may take a little bit of a break. Alex?
Oh, yeah, we've got a couple of really good ones coming up. We have Josh Morgan next week. We know that's always an exciting one. And then we have the National Hurricane Center hurricane season wrap-up coming the week right after that. We've got all the top folks there from the Hurricane Center that'll be with us on that day. So please join us the next Wednesday and the Wednesday after that. Thanks so much, guys. Really exciting program today.
Thanks.
We are in closing.